Alrighty, welcome back. Today we are going to be getting into writing out chemical reactions. And if you want to join me on page 6 of your packet, these are the examples we're going to be going over. So basically what we're doing is we're reading off a word problem or a sentence, and we're writing out with our symbols, showing the reaction that's happening, and we're balancing that reaction. So there's two steps to it. First would be to write it out with our symbols and formulas, and the second step will be to balance it. When we do this, we want to make sure we pay attention to states of matter because the word problem does state them. So when we write out our equation, we're going to be writing out our states of matter with them. Okay? So to solve these, it's pretty simple. We're just going to start off by reading the problem and just writing down what we see. Okay, so we'll go ahead and start with the first one. Solid zinc. Okay, that's the first thing. So we know it's zinc and we know it's solid. So what's the first thing I'm going to write? Zn. And then I'm going to put solid next to it. Right? Combines with. So when something is combined to, or combined with, or added to, what do you think is happening? That is the plus symbol. So combines, any kind of word like that, that means that's the plus, with oxygen gas. So we know we have oxygen and it's a gas. From the last video, we know that oxygen is diatomic, so oxygen will exist as O2 gas. To produce. Okay, so when we produce something, that means something is being made, some kind of reaction is happening. The produce is the word for our arrow. So if we have produce, makes, is formed, something like that, that's going to be where we put our arrow. And we're going to make solid zinc oxide. So we would have, for zinc oxide, because this is an actual compound, we would have to go through the charges to make the formula. So you have zinc 2 plus oxygen. Well, I put the 2 at the wrong spot. 2 minus. When I make a formula for this, you would get Zn2O2, and then we would reduce that to ZnO. So the 2's would just cross as normal, and we get ZnO. And it says it is solid, so we'll put solid. So this is just a continuation of everything we've done to this point. So if you have a compound, you're going to have to make the formula with the charges. Since we are working from home, why don't you ask your good friend Google to help you if you're struggling with making a formula. Okay, so we've written out our reaction with states of matter. So we have solid zinc, oxygen gas, solid zinc oxide. Now we can balance it. So isn't that fun? We have to do all of that work just to balance the reaction. Okay, so we have zinc and we have oxygen. We're going to count up how many we have on each side. So zinc, we have 1 on the left, 1 on the right. Oxygen, we have 2 on the left and 1 on the right. So remember, when we're doing this, we're adding a coefficient to the space, and we're multiplying that coefficient. So when I go down here to oxygen, I have 2 on the left and 1 on the right. So what I'm going to have to do is multiply the right by a number to get them to be equal. So obviously, we need to multiply by 2 so that the oxygens are the same. So I'll put that 2 in front of the zinc. What does that do to the zinc that we have up top? Well, it multiplies it by 2. So now we have 2 zinc on the right side. To balance that, we have to go to the left, multiply that by 2, and that gives us a balanced equation. So when we do these problems, there is a bunch of steps, but there's hardly any new information. It just requires you to just do a little bit of thinking and work. Okay, so there's our balanced reaction for the first one. Now, when we're done, we're going to say, okay, what type of reaction is this? And you can do this before you even start or after. It doesn't really matter. If you do it before you start, it actually helps you to solve it sometimes. So what type of reaction is this? We have 2 things forming one thing. So we know that that is going to be a synthesis reaction or a combination reaction. So what we're going to do coming up in the future pages is you're going to just say at the beginning when you start is we put, okay, synthesis reaction. We'll put that, over on the side. Okay, so that is number 1. Number 2, same thing. When solid mercury 2 oxide is heated, liquid mercury and oxygen gas are produced. Okay, so we're just going to start at the beginning, write out what we see. So we have solid mercury 2 oxide. So this is a compound. So we have to start off by saying, okay, well, I put an M. That's not mercury. Mercury is Hg. So we have Hg 2+, and then we have oxygen 2-. When I make a formula, right, we're bringing the swap. We're putting up the X, swapping the 2's. So that would give us Hg2O2. And then we would reduce that to HgO, because we have 2 2's, and they reduce. So HgO is what we'll be writing. So when we do our formula out, we have HgO, and we have solid. Okay, is heated. Okay, so when it is heated, that's also indicating that this is going to be our arrow. Okay, when we're having some kind of change happening to our reactants, that is going to be where our arrow belongs. Liquid mercury and oxygen gas are produced. Okay, so we're producing 2 things. So we have liquid mercury and then oxygen gas. When we have elements that are by themselves, they'll always have no charge up here. So when we have mercury by itself or oxygen by itself, we're never going to have any type of charges with that. We're just going to go write the element out in the case of mercury. With oxygen, we know it's diatomic. We know there's 2 down there. So most of the time when you have an element by itself, it'll just be the symbol, with the exception of the diatomics like oxygen, where it's going to be O2. Okay, so we followed off our liquid, our gas, and we produced it. So from here, we can... Oh, whoa. Clicked the wrong button. From here, we can finish off the reaction. So all that we have to do is balance it and say what type of reaction it is. So we have mercury, and we have oxygen. We have 1 mercury on the left, 1 on the right, 1 oxygen on the left, 2 mercury on the right. 1 oxygen on the left, 2 oxygen on the right. So balancing this. So it's the same as the last problem. We have 2 oxygen on the right, 1 on the left. So to balance that, we have to multiply it by a coefficient. It's going to be 2. Put that 2 up front. That balances our oxygen. And then we need to multiply our mercury by 2 on both sides to get that to balance. So there is our balanced equation. What type of reaction is this? So it's when we have one thing forming 2. So this is something breaking down into 2 things. So this is going to be a decomposition reaction. And one thing you can also add onto your reaction here is says it was heated. So when we have heat, that is denoted by a delta symbol that we put above the arrow. So that shows that heat was added. Okay, so that's balancing reactions that are written out. And this is just synthesis and decomposition. Next time, we're going to do some more complex ones.